So, good morning everyone. This is Dr. Janish Patel. I will be talking about ordinary differential equations that are useful for physics. So, in previous class we talked about these differential equations already, but today now we will see what is its importance in terms of this application in physics. So, here we see we are all busy with our day to day life. The stone rolling on the man is running, stone is running after him, and we can see some physics happening here also. What is the physics? The man is running, so what is its equation of motion? The stone is rolling down the slope, we can write down its equation of motion. So, in typical way we can look at this different scenario where the differential equation appears in physics. So, for example, we see the first example, the falling stone. So, we throw the stone from a height. So, we see that the acceleration is constant, which is equal to g, which is acceleration due to gravity. So, this is also a differential equation. This is y double prime, which is double differentiation of y with respect to time. Y is the displacement in vertical dimension. Okay, so this is d square y by dt square is equal to g, which is constant. Another example is this spring over here. You attach the mass and then you let this mass oscillate about the mean position of this mass m. So, this vibrating mass spring system would create an oscillation, so which is called simple harmonic motion. So, this simple harmonic motion can be analyzed if you write down its equation of motion, which is my double prime, which is the mass times acceleration, plus k into y, which is the spring force, is equal to 0. Okay. And similarly, over here from the electrical circuit also we can analyze the motion of electrons. The current I flowing through the circuit can be analyzed through this differential equation, right. Now, if we see this harmonic oscillator for the mass spring oscillation, so let us attach a pen to the mass, and if you put the board back to this system and then let the mass oscillate, and if you pull out the board, then what you would see that as the spring keep on oscillating, it would create some pattern on this it creates a pattern on this system. So, it is basically creating this sinusoidal wave. So, this sinusoidal wave are actually the point of interest where would actually differential equation would come in picture. Now, what are the basic concepts? So, in basically what we do is that we have a physical system, you formulate the problem in the mathematical form, which we call the mathematical model. For example, you have some variables, you have some functions, some equations, then you solve this model. So, what do? We provide the mathematical solution, and then we interpret physically, which basically means what is the velocity, what is the acceleration of the given given parameter, and based on that we actually create the differential equation and we physically simplify it. Okay. So, there are various types of differential equation. In this we are going to discuss this ordinary differential equation, which has a single function which has only one variable. So, y is changing with respect to only one variable, which we call it ordinary differential equation. On the other side, we have the partial differential equation, in which you have one function which is varying with respect to two or more than two variables. For example, in this equation we see that this function u is changing with respect to x as well as it is changing with respect to y. So, it is called partial differential equation. Now, we will focus on this ordinary differential equation and what is its use in physics. So, for example, let us say you throw a ball, okay, you throw a ball in air and it would make a curve, it would make a pattern like a parabola. Okay. So, it would make a pattern like a parabola. Now, if you take the photograph of this ball at each stage, and then if you measure the acceleration of this ball, so it would be 9.8 meter per second square. Okay. Why? Because it is a free fall. So, the moment you throw it from here, it would actually start flowing freely. So, it would have a constant acceleration and uh, from this actually we could
Focus on the
create an analysis. So, we have this equation which is mentioned over here. Now, you take the differentiation. So, differentiation of this equation would actually lead to the velocity, okay, y dy by dt is velocity, and again if you take the differentiation it would lead to the d square y by dt square, which is actually known as the acceleration. So, for this acceleration, so we know that it is constant y double dot, which is d square by dt square is equal to minus g. Now, we find for which function this differentiation is g. So, you integrate on both the side, and after integration what you would find? So, you would find that this function is actually nothing but minus g into t. So, this minus g into t plus some constant v naught. Okay. So, now this initial function value would actually let you to decide freely from where you are throwing the ball. So, y dot is equal to minus gt plus v naught. Now, again you have this curve. So, you take this function, you integrate this, and by integrating what you are getting is minus 1 by 2 gt square plus v naught t into y naught plus y naught. So, this is the differential equation what you are getting. So, what actually we have obtained here is wonderful equation which tells you that if you know the acceleration of the given object, from the acceleration, just from the acceleration, what you would obtain? You would obtain the equation that would tell you the position of this object at any later time. What will be the position of this ball after, let us say, 3 seconds? What will be the position of the ball after 10 seconds? Okay. So, this is the beauty of these differential equations. Another example would be radioactivity, exponential decay. Let us say you have some radioactive substance, for example 0.5 gram, and you want to find what would be the amount at any some later time. So, we know radioactive substance, they emit radiation, okay, they emit radiation. So, basically 0.5 gram is the mass of the substance right now. Now, what will be the mass of this substance after, let us say, 5 years down the line? It will not be 0.5 gram, it will be less than 0.5 gram, maybe let us say 0.45 gram. After 10 years, let us say it is 0.35 gram, or so it reduces over a period of time. So, what if I want to know after 20 years exactly what would be the mass of the substance, then what do I do? So, I would set up the mathematical model for this physical process. Okay. So, what is the physical process? That the rate of change of the mass, which is dy by dt, is proportional to the mass itself, y, and if you remove the proportionality constant, it is actually minus ky. So, dy by dt is equal to minus ky, okay, and this minus sign indicates that the rate of change is actually reducing over with respect to time, okay, and you have some initial value. We have 0.5 gram. So, t equal to 0 second, for t equal to 0 second you have 0.5 gram mass is left. So, if you solve this equation, okay, we apply the separation of variables, and by solving the equation what you find is y as a function of t is equal to 0.5 into e raised to minus kt. So, based on the k is the decay constant. So, for different substances this k will be different. So, you know the value of k, and then you have wonderful beautiful curve which is presented over here. It is an exponential decay. So, now you put value of t equal to, let us say 0.5. After 0.5 what would be the value of this mass y? Okay, so, it is reduced. Initially it was 0.5, and after 0.5 the mass is somewhere here. Okay. After t equal to 1 second, let us say for example, the mass is further reduced. Okay. So, this is one of the very wonderful area where one can actually utilize the power of maths in physics. So, these differential equations are very essential if you want to understand the mechanism of how this equations work, how you can actually predict, you can make the predictions that down the line what would be the status for a given particular parameter. Okay. So, thank you very much. If you have any questions, you can ask. Thank you.